Alright, so this is the review for the Chapter 4 test that we have coming up over angles and triangles. So you are going to be given this formula bank that we have here on the test day. You don't have to have any of these formulas memorized, but you do have to know how to use them. So first thing we need to do is rewrite this in negative 1400 degrees into radians. So remember to do that, we're going to take negative 1400, okay, divide that by 180, simplify that fraction, and then just multiply by pi, and we're going to keep that in exact answers in terms of pi. So let's see, negative 1400 divided by 180 as a fraction is negative 70 over 9, and so like I said, we're going to keep the pi in there, so negative 70 pi over 9. There we go. So that's our angle in radians. Alright, our second question, tires are rotating at a rate of 18 revolutions per minute. We want to find the angular speed of the tires in radians per minute. So the formula we want to use here, let's go back. Alright, and let's see. Alright, so the formula we're going to want to use is the one for angular speed, so omega equals theta over time. Alright, and let me just write that down. Omega is equal to theta over time. We want to find this in radians per minute, so omega is going to be, our theta is, so you want to think about how many revolutions are in a circle, so that's 2 pi radians. So we have 18 times 2 pi radians over 1 minute, because this is being measured in 1 minute. And from there, we're going to get equal to 18 times 2, that's going to get us 36 pi, and keeping this in terms of pi. And if this was a multiple choice question, then you would just probably multiply by pi just to see what we get out. So 36 pi, and we just want to put this in radians per minute, so rad per minute. We don't have to do any changing there for our units. It's very simple. Moving on to our next question. Each roller under a conveyor belt has a radius of 15 inches. The rollers turn. Let me just draw a picture of this as I'm going through it. So a roller there. So the radius is going to be 15 inches. The rollers turn at a rate of 40 revolutions per minute. So let me write that down. So 40 revolutions per minute. We want to find the linear speed this time. So going back to the formula bank. Right, here it is. We're going to use this one. Linear speed is equal to, or V is equal to S over T, and S is our theta. So that radius times that angle. So let me go find that question again. All right, so V equals S, or R theta, and that's the one we're going to use over time. So V is equal to R, which is our 15 inches, times theta. So remember here, it's going to be the 40 revolutions that we're looking at for the angle. So 40 times 2 pi. Again, this revolution is 2 pi every single time. So 40 times 2 pi over 1 minute. So 1 minute again. So velocity is going to be, and we just multiply all that out. So 15 times 2, that'll get us 30, and then 30 times 40, 3 times 4 is 12, so 1200. And then the linear speed, so we're going inches per minute in this case. 1200 inches per minute. That's how fast that conveyor belt is moving. And if we needed to make any conversions between like minutes to seconds or inches to feet, we could do that as well, depending on how answer choices are given. All right, moving on to number 4. We see tangent theta is 7 over 24. We want to find the exact value of sine of theta. So here we're just gonna kind of sketch out some triangle. It doesn't really matter what it is. There we go. And all right, so we're saying tangent of theta is 7 over 24. So if I put theta here, tangent of this, so tangent, remember tangent is opposite over adjacent, right? So opposite is going to be 7 over 24. We want to find the exact value of sine of theta. So sine of theta, that is equal to opposite over hypotenuse. So what we're missing here in order to convert this, but what we have given is this right triangle with 2 other legs. We're going to need to find that hypotenuse in order to give sine of theta. We're going to use the Pythagorean theorem there to find the hypotenuse. So 7 squared plus 24 squared, and then the square root of all of that, square root of all of this, that's going to get me that hypotenuse length. So we're going to keep this in exact terms. So let me see, 7 squared plus 24 squared, that's 625. Let me see if that is a perfect square. So the square root of 625, that is a perfect square. That's going to be 25. So that hypotenuse is equal to 25. So we know that this hypotenuse is 25 now. So when we find sine of theta, again, it's opposite right here. So it's opposite over hypotenuse. So sine of theta, from wherever we put that angle, so I put the angle here, and we're not changing the angle, so it's still going to be in the same spot. That's going to be 7 over 25. And that gets us the exact value of sine of theta. All right, so question 5, find the exact value of cosine theta for the triangle to the right. Again, we're going to need, very similar to the last one, except the triangle is already drawn out, but we're going to need to find this adjacent side. Look at where the angle is, cosine of theta. So cosine of theta is equal to adjacent over our hypotenuse. So we're missing this adjacent side, so using the Pythagorean theorem again, we'll figure out that A is equal to the square root of 8 squared minus 4 squared. So let's see what we get for that. 8 squared minus 4 squared. Alright, so that's 48, and we'll probably have to simplify some of that. So A is equal to the square root of 48. Let's see, I know that's divisible by 4. No, that's also divisible by 16. So since that's divisible by 16, I could do square root of 16 and square root of 3. So A is going to be equal to 4 square root of 3. Now when I actually write out this cosine theta in exact terms, as simplified as it gets, it's going to be my adjacent side, which we just found out, that's 4 square root of 3. So 4 square root of 3 divided by the hypotenuse, which is 8. And that's going to be the exact answer. Don't type in the square root of 3 or anything. Don't type in square root of 48 and start rounding out. If you give me an approximate answer, you will not get it correct. Alright, next we had the arc length of a sector of a circular patio is 7.7 meters. The central angle is 105 degrees. We will want to find the diameter of the patio. So I'm going to go back to my formula chart to figure out arc length. That's S equal to R theta. Alright, so I'm going to use that. S equal to R theta. Alright, and we're going to need to find R in this case, but also keep in mind theta needs to be, this is in degrees, we need to convert that, so we need to divide that in 180 just like we did in the first problem and multiply that by pi. So let's see what happens when that happens. 105 divided by 180. Okay, so that's 7/12, so 7 pi over 12. All right, so we're getting S, which is 7.7 meters, equal to R, which we want to find. Actually, we want to find the diameter, but we'll worry about that in a second. Is equal to what number did I just find on the calculator? 7 pi over 12. So 7 pi over 12. All right, and we're going to want to solve for the radius and then multiply that by 2 to figure out what the diameter is going to be. So let's see what happens here. So we're going to take 7.7 and multiply that by 12, and then divide that by 7, and then divide that by pi. So we get 4.2. So 4.2-ish. And the reason we're typing pi in and actually rounding this one is because this is probably going to be rounded because the 7.7 is also rounded. So 4.2 is equal to the radius. But we want to find the diameter. So remember, radius is half of the diameter. So this is going to be half of what our answer is. So we need to multiply that by 2. So 8.4 is going to be our diameter. So 8.4 actually, in terms of everything, we're probably going to want to keep this in the right units. 8.4 meters is equal to our diameter. In this question, we have the angle of elevation from the tip of a building's shadow to the top of a building is 63 degrees, and the distance is 220 feet. Find the height of the building to the nearest foot. Again, it's telling us how to round specifically for this question. So I'm going to start by drawing a picture. So that is going to be the side of my building. And the angle of elevation from the tip of a building's shadow. So the shadow is coming from here. And then we have the angle of elevation all the way up there. Alright, so this is going to be my angle theta, which is 63 degrees. So you just kind of made a triangle, and the distance is the angle of elevation from the tip of a building shadow to the top of the building is 63 degrees, and the distance is 220 feet. So we're going to measure the distance here, 220 feet. And we want to find the height. So in order to find the height, we want to figure out how these two sides in this angle are related. And what relates those is tangent. So we know that tangent theta is equal to opposite over adjacent. And notice here, this opposite side is our height, which is what we want to find. So tangent 63 degrees is equal to the height over the adjacent side, which is 220 feet. So if we multiply both sides by 220 here, and this side here by 220, we'll figure it out. So the height is going to be approximately because we're rounding it off to the nearest foot, but it's going to be approximately, let me see what we have. 220 times the tangent is 63 degrees. Well, I'm not going to type this in yet because I need to change this because I see I'm in radians, so I need to change that up to be degrees. So let me change that real quick. Document settings and change that up to degrees and make that default. Yes. Alright, so we're going to have 220 times the tangent is 63 degrees times the tangent 63 degrees, and that's going to be 431.774, so 432 feet. So the height is about 432 feet right there. So just draw a picture. Don't forget angle of elevation and angle of depression. Those are going to come up in the test. And you're going to have to draw it out straight from the given picture, or straight from the picture that you're going to have to make yourself. So here we have the side view of the skateboard ramp is this triangle. We want to find side B. So just always just draw out some random triangle. It's not a right triangle, but just random triangle. All right, there we go. A, B, C. So A is 41 degrees, B is 107, and then C, side C is 19 feet. So we have a side angle side, and we need to find side B right here. So this is going to be a law of sines question, but the first thing that we need to do is find this missing length or missing degree measurement right here. So it's going to be 180 minus these two angles. So let's see, 180 minus 107 minus 41. So it's 32 degrees. So we know angle C is 32 degrees. So C is equal to 32 degrees. And we're going to use the law of sines now to figure out side B. So it's going to say B over the sine of 107 degrees is equal to the side length of C, 19 feet, over the sine of C, which is 32 degrees. We just found that number. All right, and we need to figure out B, so we're going to multiply both sides by the sine of 107. B equals, and we'll just be typing all this in. 19 divided by, see, the sine of 32, and then times the sine 107. We get 34.3. We'll round that off to 34.3. So B is equal to, or approximately, let me switch that up, approximately 34.3 feet. So that's how long that side length is, using the law of sines. Alright, question 9. We have another triangle. It's designated for group work in the classroom. The triangle's dimensions are given. We want to find the area of the triangle. So in this case, we want to find the area of the triangle, and we're given 1, 2, 3 side lengths. So we're going to use Heron's formula, which says area is equal to the square root of S minus A, S minus B times S minus C. And to figure out S is going to be 1/2 the sum of all of those. So 1/2, 32 plus 26 plus 40. So let's see what we get from that. 32 plus 26 plus 40, and divide that by 2, 49. So S is going to be 49. And then using Heron's formula, we just put this S into all of those S's up above, and we go from there. So that's going to be what, the square root of 49. All right, there we go, 49, and then 49 minus 32, 49 minus 26, and then 49 minus 40. Oops, it's not 50, 40. And we get the area is 415.2 feet squared. So 415.2 feet squared. So you can figure out the area from that. Just using Heron's formula. If you're given all three sides, use Heron's formula. This is how you use it. Question number 10. So we have a triangle DEF. We need to find side E. Again, just draw out just some normal triangle doesn't worry, have to be perfect. So label our sides D, E, and F. So we know E is 52 degrees, D is going to be 14 units, and F is going to be 9 units. We need to find side E over here. So in order to find side E, we're going to need to use the law of cosines. So using the law of cosines, that's going to be the one that says, it looks like the Pythagorean theorem, E squared is equal to D squared plus F squared minus 2df cosine of E. And notice how we have all of this stuff and we're just looking for E. So it's going to be the square root of all of this. So E is going to be equal to the square root of D squared, and that's going to be 14 squared, plus F squared, which is 9 squared, minus 2 times 14 times 9 times cosine of E, which is 52 degrees. So let's figure out what E is, rounded probably to the nearest tenths. Alright, so we need the square root 14 squared plus 9 squared. Oops, delete that. 9 squared minus 2 times 14 times 9 times cosine of 52 degrees. So that's 11.0. Oops. Undo that real quick. Or real slow. So that was 11.0 units. Whatever units we have, this had to do with specific units, please use those units. Alright, moving on to the short answer questions. The first question is going to be sort of a definition question. And so similar to this one, an angle can be measured in degrees or what. So from this lesson or from this unit, we know that we have degrees and radians. Those are the ones with pi. Other things that you might want to know are coterminal angles, any of the formulas that we have, what they're used for, such as linear velocity, angular velocity, coterminal angle, intervals, and things like that. Alright, so here we're given a function and we want to find the exact value of the other 5 trig functions. So if I have cotangent theta equal to 6 over 17, I could kind of want to remember that cotangent, well, that's the reciprocal of tangent. So tangent of theta is equal to opposite over adjacent. So cotangent is adjacent over opposite. So I'm going to draw out a random right triangle. And then I'm going to say, alright, here's my angle right there. And the adjacent side is going to be 6, and the opposite side is going to be 17. So I need to figure out what this hypotenuse is in order to figure out the other 5 trig functions. So in order to figure out that part, I am going to use the Pythagorean theorem. So then x is going to be the square root of 6 squared plus 17 squared. So x will be the square root of 325. And we can simplify that to say x equals 5 times the square root of 13. So we know that this is 5 square root of 13. So as I'm doing the other 5 trig functions, I'm going to start with sine of theta. And sine of theta is opposite over the hypotenuse, so that's going to be 17 over 5 square root of 13. And we want to rationalize this, so square root of 13 over square root of 13, and we get 17 square root of 13 over 65. So then that's going to be sine of theta. So cosine of theta
is going to be adjacent over hypotenuse, so 6 over 5 square root of 13. Same thing, we need to rationalize our denominator. And that's going to be 6 square root of 13 over 5 times 13, which is 65. Now, tangent's going to be pretty simple. Tangent of theta, we just need the reciprocal of cotangent, so 17 over 6. And then if we want cosecant of theta, cosecant, we could just take the reciprocal of our original, so 5 square root of 13 over 17. And for secant of theta, again, we could take this reciprocal of cosine and get 5 square root of 13 over 6. So that's how we can get the other 5 trig functions. If we just wanted one of them, we wouldn't have to do all of this extra work. We want to find the exact value of secant of theta for this triangle over here. Secant of theta is going to be the reciprocal of cosine of theta, and cosine is adjacent over the hypotenuse. So since that is going to be adjacent over hypotenuse, secant will be hypotenuse over adjacent. So again, we need our hypotenuse here, and in order to get that, we'll go h is equal to the square root of 20 squared plus 30 squared. So h will be 1300, the square root of 1300. I could factor out 100 from that, so h is going to be 10 square root of 13. So now when I want secant of theta is going to be the hypotenuse right here, so 10 square root of 13 over the adjacent side to the angle, which is right here, 20. And this can be simplified. We could simplify that. 10 over 20 is 1/2, so square root of 13 over 2. So if theta is equal to negative 476 degrees, we want to find one positive and one negative coterminal angle. So remember, for coterminal angles, you just go in the circle. So you want to go 360 degrees or 2 pi if you're in radians. And you just want to go all the way around in the positive or negative direction. So if I'm at negative 476, I just want to end up in the exact same spot that I was. What I'm going to do here is I'm going to take negative 476 and I'm going to add a full circle. So negative 476 plus 360 gets me negative 116 degrees. Now this would be one negative coterminal angle because this is negative. But I could have also gone negative 476 degrees minus 360, negative 836 degrees. That's also a negative coterminal angle. What I could do to this negative 116 degrees is add 360 again and get 244 degrees. So either one of these would work as a negative coterminal angle. Of course, you can make multiple paths around the circle. And then this one over here, the 244 degrees, would be one positive coterminal angle. All right, and then finally, in triangle ABC with A equal to 59 degrees, B is 12, and C is 4, we want to find the area rounded to the nearest tenths. Okay, so I'm going to draw out just a random triangle. And so I'm going to name this A, this top one B, and this side one C. So A would be 59 degrees, B would be 12 inches, and C would be 4 inches. Alright, and what I need to do is I want to use Heron's formula so that I can get the area of this triangle, and I want to find like all this space inside. But I need the third side in order to do that. So I'm going to find the third side using the law of cosines. So if I do that, if I want to figure out what A is, that'll be the square root of 4 squared plus 12 squared minus 2 times 4 times 12 times the cosine of 59 degrees. So A is approximately, and I'm going to round this one to 4 decimals, even though I know I need to go to the tenths because I want the final answer to be a little bit more exact. Alright, when I type all that into the calculator, I get 10.5146. Alright. Now, what I'm going to do here is use Heron's formula, and that's just at the top of this page up here. I need S, and then I take the square root of all the sides subtracted. Okay, so this I'm going to put over here 10.5146. So S is going to be 1/2 of 4 plus 12 plus 10.5146. Alright, let's figure out what that number is. So S comes out to be 13.2573. So now when I plug that number in, and instead of writing this number out multiple times, I'm just going to keep using S. Actually, no, I'll write it out. So the area is going to be equal to the square root 13.2573, and then 13.2573 minus the first side, which is 4, then 13.2573 minus the next side, which is 12, and then 13.2573 minus 10.5146. We're going to take the square root of all that. So let me put that into the calculator. Alright, after I put that into the calculator, I get my area is approximately, and I want to round this to the nearest tenths, so 20.6. Since I'm working in some units, I'm going to have inches squared because this is area. Alright, and then finally on this last question, we want to find all the missing parts of this figure down here. I'm not going to find the entire thing, but we're going to find just a little bit of it. And you can see how you kind of build this triangle out. So what I notice here is I can find J by going, because this inner triangle is going to be 180 degrees, so 180 degrees minus 53 minus 27. So I know that J comes out to be 100 degrees. So let's see what I can do now. I can use the law of sines to find side B over here. So in order to use the law of sines, I would have B over the sine of 100, which I just found. And then I'm using this side angle pair right there. So 92 over the sine of 53. Multiply both sides by the sine of 100. And we get B is approximately, let me type that in. So B comes out to be approximately 113.4. Okay, we don't really have any units here, so I'll just leave it 113.4. Now going from that, I notice here that I have a side angle pair right here. And if I want to find angle A, I could use the law of sines again with that side angle pair. So we'll do that real quick. So angle A would be sine of A over 63 equals sine of 76 over 113.4. So multiply both sides by 63. So now I have sine of A equal to 63 sine of 76 degrees over 113.4. And then to solve for A, I need the inverse sine of both sides over 113.4. Okay, I put that into my calculator, and I get A is approximately coming out to be about 33 degrees. So this one here is going to be 33 degrees, and we're going to round that to the nearest degree. Well, since I have 76 degrees and 33 degrees, I could figure out side C, or angle C, sorry, just by subtracting those from 180. And once I have that one set up, I could find side C over here. Doing similar things just by setting up all the sides and going from like the law of cosines or the law of sines, I could find every missing piece of this triangle. So if you want to work through finding the missing parts of this figure, then you can come work on that individually with me. But that's going to be a start to finding all the pieces of this open response question. I hope you guys all study well for the upcoming test. I'm Mr. Hernandez, and I'm always here to help.